Hey guys, today we are going to do section 11.3, which is polynomial inequalities. And first, we're just going to look at this example right here graphically. It says use the graph of the polynomial to solve x to the third plus 2x squared minus 3x is greater than or equal to 0. Okay, and we're going to actually write our solutions in interval notation. Okay, so we're going to be using our brackets and parentheses. First off, we need to understand that we only want the solutions when the polynomial is greater than or equal to 0. So I want all the solutions that are basically above the x-axis, okay? So first, let me identify where the x-intercepts are. They are when x equals -3, 0, and that looks like 2. Is that 2 or what? Oh, no, that's 1. Sorry, my bad. That's 1. Okay. So from here, now we just want to show the solutions when this polynomial is greater than 0. So everything that's up here in this area, okay? So from here to here, the function is greater than or equal to 0. So from -3 to 0. And we want to include those points because the function is allowed to equal 0. So we're going to put brackets on those guys, all right? Then the function is also greater than or equal to 0 right here on this part of the polynomial, and that is when the x value is 1 and it's going towards positive infinity. Always use a parenthesis on infinity symbols. The x value can be 1 because it can equal 0. And remember, this is the union sign. This just means and. Okay, so let's just practice using our good math notation there. All right, so that's how you can solve these based off of a graph. But we're not going to graph each one of these down below, okay? So the steps to solve polynomial inequalities are down here. First, we're going to write the inequality in factored form. We're going to identify the zeros. We're then going to graph the zeros on a number line. Then we're going to pick a test point or test value for x that falls on the interval created by the zeros. I'll kind of show you what that looks like. Evaluate each interval and then state the solutions in interval notation. Okay, that's your brackets and your parentheses. Don't forget. Okay, all right. So number 1. To first solve this, we need to factor it, right? So let's go ahead and say, well, x times x equals x squared. My only factors of 2 are 2 and 1. These need to add or subtract to get -1. So let's see, -2 plus 1. Okay. Let's set that equal to 0. So x equals -1 and positive 2. All right. So we've identified the zeros. Now we're going to pick zeros, or I'm sorry, graph the zeros on a little number line here, okay? So I've got -1 and I've got 2. Now, remember kind of back in Algebra 2, these inequality symbols represent open circles, okay? These are open, these are closed. And we want to use parentheses on these guys, and we use brackets on the less than or equal to or greater than or equal to symbols, okay? All right, so from here, I'm going to plot these, both open circles, because we just have a less than sign with no line under it. Then we're going to pick a test value. I'm going to pick 0, so I'm going to say my test point is x equals 0, okay? So if I plug 0 back in for x right here, I'm going to get 0 squared minus 0 minus 2, which is just going to be -2, is less than 0. Oh, I'm sorry, you guys can't see that. All right, so all I did was plug 0 in right here. Then I need to determine if that statement is true or not. That statement is true, yes, okay? So that means my solutions are in between right there, okay? If the statement was not true, then you would know that your shading goes on the outside here, okay? So because it's true, that's my interval. So my solutions fall in between -1 and 2, and I'm using parentheses because the solutions cannot equal -1 and 2. All right? Okay, number 2. All right, first we need to write this into factored form. So let's see here. This is a difference of squares because I'm going to take the square of the first term and last term. So I have x squared minus 9 and x squared plus 9 equals 0. Now you could factor this further because this is a difference of squares. So x plus 3, x minus 3, x squared plus 9. We can't factor that further. That's not a difference of squares, okay? So x equals plus or minus 3, right? Then I also can set this equal to 0 and solve, but realize here that these are going to be imaginary because when I do x squared equals negative 9, I get x equals plus or minus 3i. And those don't show up on the x-axis, so we don't really need to worry about those guys, okay? So I'm just more concerned about this negative 3 and positive 3 here. So I've got negative 3 and positive 3. These are going to be closed dots because we have a line underneath our inequality sign. Let's test the point 0, when x equals 0, sorry. Test point, x equals 0. Let's use that, guys. Always try to use like an easy number that's not like super big, okay? Work smarter, not harder, right? Okay, so if I plug 0 in right here, 0 to the 4th is just 0, and so then I get negative 81 is greater than or equal to 0. That statement is not true, okay? So that's a big no-no. So that means that our solutions do not lie here. They actually are going to lie out here. So to write this in interval notation, we would say we go from negative infinity. Remember, we want to read from left to right, smaller numbers first. So negative infinity to negative 3. Always use parentheses on infinity. That's going to represent a bracket. And we go from 3 to positive infinity. Again, I'm going to use a bracket on this 3 because that is the function can equal 0 at 3. Okay? Alrighty, let's do number 3 and 4. Okay, number 3. We've got an issue here. This is not equal to 0, right? So let's move this 4x minus 4 over to the other side. So I'm going to get x to the third minus x squared minus 4x plus 4 is greater than 0. Okay, so I subtracted the 4x and I added the 4. All right, this is going to be a factor by grouping problem because I have 4 terms. So my GCF of the first group is x squared. I'm left with x minus 1. My GCF of the second grouping looks like I'm going to want to take out a negative 4. So then what I have left in parentheses matches. And I can actually set this equal to 0. Matches what's inside in parentheses over here, right? Those have to be the same. All right, then I combine my GCFs to make one factor. And since x minus 1 is the same, I'm good to go. I could factor this a little further. X plus 2, x minus 2, because that's a difference of squares. These all equal 0. So x equals plus or minus 2 and 1. All right, so we've got a lot of numbers here on this number line. So let's see, negative 2, 1, and 2. Now these are all going to be open circles because I do not have a line under my inequality symbol right there, okay? All right, from here, I'm going to test 0, so x equals 0. Let's see what happens. I'm going to plug it into this equation, okay? So 0, 0, 0, so 4 is greater than 0. That statement is true, yes. So I can shade right there, okay? You could have plugged 0 back into this original one, and that would have been totally fine, okay? And then let's test, I don't know if I really want to do the 1/2. Let's do like a 3 right there. Let's plug in a 3. So let's see here. We're going to have 3 to the third, minus 3 squared. I'm just doing this on my calculator to check real quick. Minus 4 times 3 minus 4. Did I do that right? Minus 4. Oh, no, plus 4. Sorry. Okay, so I get 10. 10 is greater than 0. That statement is true, so I can shade over here. Okay, which kind of like eliminates these two areas that the function will not work right there. Okay, so my solutions are going to be from -2 to 1. All right, and remember, you use the union symbol, 2 to positive infinity. Now remember, we did not put brackets on -2, 1, and 2. We just use parentheses because this is open, and always use parentheses on infinity symbols. Okay, and another guy over here. Again, we're going to have to get this all on one side. So we have 2x to the third, a minus 3x squared. I'm going to write this from highest to lowest degree. Minus 32x plus 48. 48's already over there. Is less than or equal to 0. Okay? So this is the equation that I'm working with here. All right, this is going to be another factor by grouping problem. So let's do it. So I get x squared, 2x minus 3. Oh, what's the GCF there? -16. X. Oh, whoops. Not 2x. Sorry. See, we make mistakes sometimes. 2x. Let's see here. Minus 3 as well. Okay. Now, combine your GCFs together. And 2x minus 3. Those are the same in parentheses, so I'm good to go. Alrighty. This would be x plus 4. X minus 4. 2x minus 3. Equals 0. So x equals plus or minus 4 and 3 over 2. Okay? So, let's draw this on number line. Got -4. 3 over 2 would be in between -4 and 4. Okay. So, these are all closed because the function can equal 0. Okay. Then, I gotta use test point. Let's use 0 right here. So when x equals 0, let's see what happens. Okay, 48 is less than or equal to 0, right? If I plug a 0 in right there, anything times 0 is 0, okay? So that statement is not true. No. So we are not going to be able to shade there, okay? I'm going to use a 2 right here just to check. Okay, so I'm going to type this in my calculator real quick just to check it out. Let's see. Minus 3, 2 squared, minus 32 times 2 plus 48. I'm going to get -12 is less than or equal to 0. That statement is true, so my solutions do lie here. Okay. We probably want to check. I'm assuming that it's not going to exist over here just because it did exist in this interval. You always can use a test point though right here just to double check that out, okay? And then I'm also going to test over here though, less than -4, so I'm going to use -5 over here. And I'm going to see what happens, okay? So let's see here. Whoops. 2, -5 to the third, minus 3 times -5 squared, minus 32 times -5 plus 48. Oh yeah, okay. -117 is less than or equal to 0. That statement is true, so I'm going to shade this direction, okay? Like I said, I recommend maybe just using a test point right here just to double check that out. There's nothing wrong with checking your answer, right? So my function exists from -infinity to -4, okay? Parentheses, bracket on the -4 because it can equal it, and it exists from 3 over 2 to 4, and brackets on both of those guys because the function does equal 0 at that point. All right? Oh, whoops, sorry, you guys can't see that right there. That's what your final answer should look like. All right, I've got one more for you guys if you want to stay on. Okay, on the back side, let's see here. I want to go ahead and this one's a little different. You could FOIL this out if you wanted to, but remember how I always say let's work smarter, not harder. Okay, we can go ahead. We just need to solve for x, right? We just need the x values. You could just take the square root of these, both sides, and get rid of that. Okay, so then you would be left with x minus 3 is less than, well, we're just solving for x, so we don't need to worry about that symbol quite yet, equals plus or minus 1, right? When you take the square root of a number, you get plus or minus for the version of it, okay? So I have x minus 3 equals 1, and I have x minus 3 equals negative 1. So I need to solve both of those two equations. So x is going to equal 4, and x is going to equal 2. All right? So let's draw that on a number line. All right, these are going to be closed circles because the inequality symbol has a line under it. All right, let's just go ahead and use x equals 0 as a test point over here, and let's see what happens. 0 minus 3 is negative 3. Squared is 9. Sorry. 9 is less than or equal to 1. That statement is not true, so I'm going to cross that part out, okay? Let's try 3. I'm assuming it's going to work, but let's just double check. 3 minus 3 is 0. 0 squared is less than or equal to 1. That statement's true, so I can shade right here. And again, like I said, you could use a test point over here. 5 minus 3 is 2. 2 squared is 4. 4 is not less than or equal to 1, so I'm not going to shade there, okay? So always use a test point just to double check yourself if you want. Okay, so my interval would be from 2 to 4, and I'm using brackets because I have closed circles. All right, I hope this video was helpful. You guys have 5 homework problems below. Make sure you guys get those done, and I will see you in class soon. Bye.